Boone.
Is it just JV or is
Got
it
tennis. We got JV and varsity.
ready?
Let's see.
Who's your number one?
Jomer.
I thought it was Lyman.
No, he's doing a nice job. Can you hit that door?
Yeah.
Thanks. All right, so logarithms are the exact opposite of the exponential form. That exponential form was the y equals a times b to the x. Okay, but we're going even simpler this time. Our exponential form, we're going to say is just y equals b to the power of x. And we are going to go to the log form, the logarithm, which is the inverse. It's the exact opposite. And we're going to say it's log, so that's just like the button on your calculator. It's like a word. And then we're going to go subscript, which means like a little letter underneath. So log base b, it's called a base, of y equals x. Now the nice part about switching between the two of them is that we're using the same three numbers every time. We're just kind of rearranging the order. Okay, so we have ybx over here, we have ybx over here. We're talking about the same exact numbers. So it's the inverse. We have a lot of notes to compare to some other days, so just bear with us. Are we good to go? All right. First example. We are going to start with the log with the base 2, so that's like the little 2 underneath, of 1 over 8. So that 1 over 8 is on the same line as log, like the 2 is below it. The log and the 1 over 8 are in the same line. And it's going to equal -3. So we want to go from the log form and we want to turn it into the exponential form. So like if our computer, and computers talk like this, if our computer was like had code with like log base 2, 1 over 8 equals -3, and we wanted to like graph this or figure out like what this looked like in a picture in real life, this is kind of what we would do. So we're going to end up in the exponential form. Let's find our three numbers that we need. Okay, we know that this little b right here, this little number, is b. So b equals 2. And I'm just looking back at like the skeletons of the very first notes that we took. So the little b is 2. The y is going to be that number in parentheses. So y is 1 over 8. And then x is the number at the end. And after we kind of rearrange all these letters and numbers, it should just make sense, like when we look at this equation. So let's plug them back into y equals b to the power of x. So we're going to plug it back into the skeleton. What's our y value that we found? Yeah, 1 over 8. So 1 over 8 equals b. Now it's a big B, but it's still the same number. So even though it's little up here and it's big down here, it's still the same number. So our b, our base is 2. So equals 2 to the power of x. And what was our x? -3. Yep. And that would be our function, or our exponential form. Now, if you think about it, it just kind of checks out. When you have a negative exponent, you're going to have to make a fraction and put this on the bottom. And then 2 times 2 times 2 is 8. So it ends up being 1 over 8. So if you're ever not sure, you can just kind of do it in your head or plug it into a calculator and see if it works. We'll do another. We're going to evaluate the log. Evaluate the logarithm. So this one is log base 9 of 9 squared. And what are we missing from this logarithm equation right now? Which part of it? Yeah, the x, the equals x. So they're not going to tell you that in the problem, but you just know that it should equal x, but they don't tell us. So if you want to write that lightly or something like that, just so you know that that's what we're going to solve. So we know our b, this little base, is 9. The small number is the base, that's 9. Our y is the number in parentheses. And we don't want to write it like 9 squared. We want to make it a nice whole number. So what is 9 squared? 81. Yep, 9 times 9 is 81. And then we have no idea what x is. That's what the evaluation part is. We're just going to solve it. And a lot of these you can just do in your head by looking at the equation. So we just need to set up our equation. So y equals, so 81 equals, so y equals b to the power of x. We know that our b is 9. And we know that our power of x is something that we don't know, so we can just leave it as x. And then just looking at this equation, we can figure out what x should be. So 9 to the power of what is 81? 2. That's it. You just solved the logarithm. So you might use this, not maybe this like specifically, but like if you were working at a desk job and you were working with computers or programming or something like that, or even like in a system in a company, maybe they give you your factory formula of how efficient your company works and how many shipments go out, and you need to figure out how many times through in a day that cycle needs to go. You just figured out if it goes 2 times, you're breaking even. Okay. Next one. Very similar. We're going to evaluate the log. So I want you guys to kind of try this on your own, and I'll step in and help a little bit. So we're going to evaluate the logarithm, and it's going to be log base 9 of negative 81. And then what part are we missing of this equation? X. Yep. So I want you to find your b, your y, and your x, and then see if you can solve the equation. You guys set it up something like this. My y equals b to the power of x is really negative 81 equals 9 to the power of x. So this is kind of tricky. We're trying to find what number x could be. Would anything with an exponent ever equal a negative? Not with a positive base. So 9, there's no possible power that 9 could be to make it a negative 81. If it was 9 to the first, it'd be 9. If it was 9 to the second, it'd be 81. If it was 9 to the negative 2, we'd flip it into a fraction, be 1 over 81. So no possible exponent in this problem would make it a negative. So we would say no solution. Yep. About halfway done. It's a long day. We'll have today and tomorrow. We can make a little key for ourselves. So we've been working with the with the log, with just like a normal logarithm. There are also the natural log, which is just the log base of e, or 10. Yeah, I think it's log base 10. But we can kind of flip back and forth between the two. So sometimes in math and in computer programming, like we want to take the shortest way possible. And so there's some things that we assume and we can just take out. Like the computer already knows it automatically. So one of those things would be if you ever see log of x, that's the same thing as log base 10 of x. So if there's no base, you can assume it's 10. Base 10 is what we use most of the time. The natural log is the same thing as the natural log of e with a base e. So normal logarithms have a base of 10. Normal natural logs have a base of e. And then the natural log of e equals 1. Okay, 2 more examples. These are kind of more real life, dealing with time. So we're going to solve for t here. And t just means time. Solve for t. So let's say we have 3.25 e to the power of t. And remember, e is it's like a button on your calculator. It's a number. 2 point something. Equals 47.4. So do we see a log or an ln in this problem? Nope, so we're just going to solve it like normal. If we wanted to get that letter t by itself, what's the first thing that we could do? How could we get rid of the 3.25? Yeah, divide, because there's like an imaginary time sign right there. So let's divide by 3.25. And so what's left over is e to the power of t equals, it ends up being 14.56, oh no, 58, 426. Okay, so right now we want to find the answer in the exponent. There is no good way to do that we know right now. Okay, so we're going to use this table, or this key that we just made, and we know that the natural log and e are directly related. They're kind of the exact opposite of the same thing. They cancel each other out. So what we're going to do to cancel this e and get t by itself is take the natural log of e on the base of 14.58426, and that's going to equal our t. So by taking the natural log, we are canceling out the e on the left side. That's basically what we're doing. So I want everybody to get their calculator out. Let's practice using the natural log on the calculator. So there's an LN button, third down on the left side, hit LN. So hit the LN button, and then we don't need to do anything for the E because natural log assumes that base of E. So just hit LN and then type in this number. Hit enter, and it'll tell you your answer. Should be like 2.6800. This is probably some of the craziest math you've ever done and may ever do in your life. The big thing is, do you guys know why we chose the natural log to cancel out the E? Do you guys see that part? So back on this key, the natural log and E are related. So if we had a base 10, for example, in a problem, what would we use to cancel it out? The log button. Okay, that's basically all. It just cancels it out of your equation. So we're going to do one more that's very similar. We're going to solve for t again. But this time we have a base of 10. And then our exponent is t plus 1. And that's going to equal 57. Now this equation right here is y equals b to the power of x. The y is just on the opposite side. It's just y equals b to the power of x. So let's figure out what our b, what our y, and what our x are. So what's the base that we have? What's the big number? 10. It's like b to the power of x. Y is the number by itself, so that's 57. And then x is the whole exponent, t plus 1. Now that we know b, y, and x, we can go from the exponential form and turn it into the log form, just like we've done on 7 other problems already today. We're starting in y equals b to the x. We're going to go to the log form. So that's log. And then what's our base? 10. Yep, that's our b. And what's our y? Yep. And that equals our x, which is actually t plus 1. So on your calculator, get your calculators out. We're going to hit the log button. The log button second down on the left. So hit the log button. Do we need to type in the base 10 or does the calculator assume it? It assumes it, right? So just put log of 57 and tell me what you get. Round to 4 decimal places. Should be like 1 point or 0, yeah, 1 point something. 7? 1.7559. And that still equals t plus 1. But we want to get t by itself. So how can we move that plus 1 over there? Yeah, just minus 1. So our answer is actually going to be 0.7559 for our t.